In this example, we are being asked to solve the system of equations using matrices and put the system in reduced row echelon form. Now, this system is the same system that we saw in a previous example, so we should know kind of what we're getting to. So you could flip back a couple pages in your notes and see how we solved this system before. This is the one that we put in matrix form, and we did some matrix manipulations, and then we did back substitution. But now we're not going to use back substitution. We're going to put this in fully reduced row echelon form. So the first thing we want to do is write this as an augmented matrix, right? So we open up a matrix bracket. We've got 2, 1, 1, -1, partition line, 2, 0. Okay, so this part is nothing new. All right, now the first thing I'm going to do, I like to put all of my rows that start with a 1 into the higher rows. Okay, so I'm going to say, let's do a row operation here. I'm going to say interchange row 1 with row 2. And remember, the double arrow means row interchange. Okay, and so when I do that, my row 1 is up here now, and my row 2 is down here, okay? And here's my partition line. Now, again, why did I do that? Well, we're trying to get this in reduced row echelon form. So what you want to make sure you do is you want this leading value here to be the number 1, okay? That's the idea of reduced row echelon form, right? The main diagonal is all 1s, all right? So let me just delete that little dashed circle. All right, what do we do next? Well, we need to somehow create a cancellation, okay? We want to create a cancellation of this 2. You got to ask yourself, how do I get the left part of this matrix into the form where the main diagonal is all 1s and everything else is 0? So we want to create a cancellation in this lower triangle, all right? So what I'm going to do is I'm going to say -2 row 1 plus row 2 to change row 2. Okay, so I'm using row 1 to modify row 2. But I'm not actually doing anything to row 1, so I'm going to keep row 1 the same. I'm just using row 1 to change row 2. So what happens? I'm going to say -2. I'm going to say -2 times row 1 plus row 2. So that becomes -2 plus 2, and so you get 0 here, okay? Next, we say -2 times -1 is +2 plus 1 is +3, okay? What do we do next? -2 times 0, -2 times 0 is 0, plus 2 is 2. There you go, okay? Now, this step, we actually did pretty much these exact same steps in our previous example from last class's lecture, okay? So you should have this much already in a previous part of your notes. But we need to keep going, right? How do we continue to work towards reduced row echelon form? Well, we already have a leading 1 here. We need a leading value of 1 in this entry where this 3 is. So watch what I can do. I can perform another row operation, and I can say 1/3 times row 2 just to change row 2. So all I'm going to do is I'm going to operate on row 2, and that's okay, right? What am I doing? I'm just multiplying a row by a non-zero constant. That's perfectly allowed. That's one of our elementary row operations from a few pages back in your notes. So you need to maybe refer back to those if you don't remember. So when you multiply 1/3 by row 2, you have 1/3 times 0, 0. 1/3 times 3 is 1, and then we get 2/3 here on the right of the partition. Now, here's something cool, okay? This left portion of the matrix, what is this in now? This is row echelon form, okay? So we have now achieved row echelon form on the left side of the matrix, okay? That's great, but we got to keep going. We want reduced row echelon form. So what do we do now? Well, we need to create a cancellation in the upper triangle. We need to somehow cancel out that -1 that's in the upper triangle. So what do? We're going to perform another row operation. We're going to say row 2 plus row 1 to change row 1. So here, we're using row 2 to change row 1. And specifically, our goal is to cancel this -1 here, okay? So let's open up a new matrix. Now, at this step, are we actually changing row 2? No. No, we are not. So we are going to repeat the entries of row 2 at this stage, okay? We are not actually changing row 2 here. We are using row 2 to change row 1, okay? So what happens when I say row 2 plus row 1, one entry at a time? You'll get 0 plus 1. Well, that keeps it 1, okay? And then you have 1 minus 1. So that changes this entry to 0. And then you have 2/3 plus 0. And so this entry up top becomes 2/3. Now look at what we have here. The left portion of our matrix right here is now in reduced row echelon form. This is what we wanted. And now check this out. If we put this back into equation form, what do we get? We get x equals 2/3, right? X, this is the coefficient for x, plus 0y equals 2/3. And then what's the second equation? 0x plus y equals 2/3. So that's just y equals 2/3, and that's our final answer. So that's it. So here's the beauty of reduced row echelon form, okay? Putting the coefficient matrix in reduced row echelon form will yield the exact final answer that we're looking for the system, okay? So that's the beauty of reduced row echelon form. So that's going to be the end of this video. We'll do a couple of more example videos on this topic right after this one.